Hello friends, welcome to the 7th video in the series of videos on Introduction to Swift. In this video, we will learn about initialization, de-initialization and automatic reference counting in Swift programming. Initialization. Initialization is the process of preparing an instance of a class, structure or enumeration for use. This process involves setting an initial value for each stored property on that instance and performing any other setup or initialization that is required before the new instance is ready for use. Initialization process is implemented by defining initializers, that is init methods, that can be called to create new instances of a particular type. Unlike Objective-C, Swift initializers do not return a value. Classes can also implement de-initializers which perform the cleanup before an instance is deallocated. In its simplest form, an initializer is like an instance method with no parameters, written using the init keyword. For example, here we have defined a structure called rectangle with length and breadth properties. The init method here provides default values to length and breadth properties. Observe that init method in this case does not have any parameters. So when we make an instance of rectangle struct, its init method is called and properties are set to 6 and 12 as shown. Now we can calculate area by accessing these properties. Parameterized initialization. You can provide initialization parameters as part of an initializer's definition. Initialization parameters have the same capabilities and syntax as function and method parameters. As with function and method parameters, initialization parameters can have both local and global parameter names. Swift introduces an automatic external name for each and every parameter in init. This automatic external name is as equivalent to local name written before every initialization parameter. If you do not want to use an argument label for an initializer parameter, write an underscore instead of an explicit argument label for that parameter to override the default behavior. For example, class square has a parameterized initializer which takes only one parameter called measured. Measured here is a local parameter. If you don't want to use a parameter name at the time of creating an instance of this class, just write an underscore before the measured parameter name. And when creating an instance, directly pass the value without any parameter name. When the stored property is declared as optional, it automatically initializes the value to be nil during initialization itself. Initialization also allows the user to modify the value of a constant property. Swift provides a default initializer for any structure or class that provides default values for all of its properties. So when class does not provide any one initializer itself, Swift provides a default initializer. Structure types automatically receive a member-wise initializer if they do not define any of their own custom initializers. Initializers can call other initializers to perform part of an instance initialization. This process is known as initializer delegation, and it avoids duplicating code across multiple initializers. Value types like structures and enumeration do not support inheritance, and so their initializer delegation process is relatively simple because they can only delegate to another initializer that can provide them that they provide themselves. For value types, we use self.init to refer to other initializers. Swift defines two kinds of initializers for class types to help ensure all stored properties receive an initial value. These two types are designated initializers and convenience initializers. Designated initializers are the primary initializers for a class. A designated initializer fully initializes all properties introduced by the class and calls an appropriate superclass initializer to continue the initialization process up the superclass chain. Every class must have at least one designated initializer. In some cases, this requirement is satisfied by inheriting one or more designated initializers from a superclass. Convenience initializers are secondary, that is supporting initializers for a class. You can define a convenience initializer to call a designated initializer from the same class as the convenience initializer with some of the designated initializer's parameters set to default value. You do not have to provide convenience initializers if your class does not require them. Create convenience initializers whenever a shortcut to a common initialization pattern will save time or make initialization of the class clearer in intent. Convenience initializers are written in the same style but with convenience modifier placed before the init keyword. For example, here we have designated initializers for both the classes. Thus, when we want to make an instance of main class, we pass only one parameter as expected in the main class initializer. When defining an instance of the subclass, we pass two parameters as expected by the designated initializer in the subclass. In this example, we have explained the use of convenience initializer. For subclass, we have one designated initializer and one convenience initializer in case of default value for property number 2. Now we can define an instance of subclass with only one parameter passed to initializer, like this. Failable initializer. Sometimes initialization can fail for a type due to invalid parameter values or absence of required external resources or some other condition. To handle these conditions where an initialization can fail, we can define one or more failable initializers as part of a class structure or enumeration. Failable initializers are written by placing a question mark after the init keyword. You cannot define a failable and a non-failable initializer with the same parameter types and names. You can use a failable initializer to select an appropriate enumeration case based on one or more parameters. A failable initializer of a class, structure, or enumeration can delegate across to another failable initializer from the same class, structure, or enumeration. Similarly, a subclass failable initializer can delegate up to a superclass failable initializer. You can override a failable initializer with a non-failable initializer, but not the other way around. Non-failable initializers can never delegate to failable initializers. De-initialization. A de-initializer is called immediately before a class instance is deallocated. De-initializers are written with de-init keyword. De-initializers are available only for class types. Swift handles the memory management of instances through automatic reference counting, that is ARC, and thus automatically deallocates your instances when they are no longer needed to free up the resources. Usually, we don't need to perform manual cleanup when our instances are deallocated. However, when you are working with your own resources, you might need to perform some additional cleanup yourself. For example, if you create a custom class to open a file and write some data to it, you might need to close the file before the class instance is deallocated. Class definitions can have at most one de-initializer per class. The de-initializer does not take any parameters. For instance, in this class called de-initializer, we have defined an initializer and a de-initializer. Initializer is called when an instance is created, and de-initializer is called when the variable reference to the instance is set to nil. As shown here, we have created an optional variable called de-initial of type de-initializer. This line calls the init method in class and prints the value of count after incrementing it by 1. In next line, when we assign a nil value to the reference variable, de-init is called and it decrements the count value by 2 and prints the same. ARC, that is automatic reference counting. Swift uses ARC to track and manage memory usage in your application. ARC automatically frees up the memory used by class instance when those instances are no longer needed. Reference counting only applies to instances of classes. Structures and enumerations are value types and are not passed or stored by references. Every time you create a new instance of a class, ARC allocates a chunk of memory to store information about that instance. This memory holds information about the type of the instance together with the values of any stored properties associated with that instance. Additionally, when an instance is no longer needed, ARC frees up the memory used by that instance so that memory can be reused for other purposes. This ensures that class instances do not take up a space in memory when they are no longer needed. That's it in this video. In next video, we will learn about optional chaining, typecasting, and extensions in Swift programming. Thanks for watching.